Hello, ladies and gentlemen of algebra class. This is Ms. Pashauer talking to you. We are going to be talking today about section 4 of chapter 7. It is called dividing exponents. We're going to be talking today a lot about dividing when we have things, powers with exponents. So something to remember, a key concept to remember would be that anything divided by itself has to be equal to 1. Or as a fraction, any numerator and denominator that are exactly the same, 3 over 3, are going to basically cancel out or divide out and make 1. Let's look here at our first problem, 3 to the 4th over 3 to the 2nd. Something to notice is that our bases are the same. We have 3 here as a base and 3 here as a base. 3 to the 4th is the same as 3 times 3 times 3 times 3, 4 times on the top. We can write that out. And 3 to the 2nd is the same as 3 times 3. 2 times here in the bottom. And so something that we should notice is we're going to have some canceling out, as what we talked about here in number 1 in our key concept. So what happens is a pair of 3's here will cancel out, and a pair of 3's here will cancel out. We'll be left with just 1's. Okay, so these are canceling out and making 1. 1 times 3 is the same as 3 to the 2nd. Okay, on the bottom, we're left with only 1 times 1, so we're just going to get a denominator of 1 on the bottom, and this is equal to 3 to the 2nd, or if you really wanted to keep evaluating, you would obviously write 9. 3 to the 2nd is 9. Okay, let's try another one. In this case, we have 6 to the 7th as a numerator and 6 to the 3rd as a denominator. I'm going to write that out so we can see a pattern and hopefully use this pattern that we're seeing here to write a nice formula that will help us in problems to come and help us so we don't have to write out all this times sort of things. But let's see if we can see the pattern. What's going to happen is we're going to write 7 6's here. 1, 2, 3, 4, 5, 6, 7. 6 to the 7th, and then 3 here on the bottom. Again, we have pairs that will cancel each other out. Okay, this pair of 6's, they'll cancel because they become 1 and 1. 6 divided by 6 is 1. These 6's here will become 1, and then these 6's here will become 1. We're left with 4 of them. 6 to the 4th. Now hopefully we can see a pattern here. I have 4, 2, and I'm left with 2. I have 7 as an exponent and 3 as an exponent. I'm left with 4. Does anyone see the pattern that we should see happening here? A formula that we can write. Yesterday we were multiplying with the same bases and we added the exponents. Today we're going to subtract. Okay, today we're going to subtract. This is important. To divide powers with the same base. If they have the same base, you can keep the base and subtract the exponents. We could have gotten this 2 real quick by going 4 minus 2. We could have gotten this 4 real quick by going 7 minus 3. Okay, always top, take away bottom. Okay, so the most important word here is that word subtract. Go ahead and take a second, pause the video, copy that down. All right, next, hopefully you have that copy. Now we're going to do some example problems. We're going to do 3 together that I will walk you through. Numbers 1, 2, and 3. And you're going to do 4, 5, and 6 on your own and check them with the answers that will happen here. So our first problem, 10 to the 3rd times 10 to the negative 3rd. Well, remember, we don't like dealing with negative exponents. We're going to try and get rid of that. And so then we can see that, 10 to the 3rd here, we can write as 10 to the 3rd over 1. Anything can be written over 1. Times 10 to the negative 3rd. Well, what happens is 10 to the 3rd times 1 is going to give you 10 to the 3rd. We're just multiplying across. 1 times 10 to the 3rd on the bottom is going to give you 10 to the 3rd on the bottom. And again, all of that's going to simplify down to 1. Same thing on top as on the bottom. Some of you might see, Ms. Pasha, I could have gotten that earlier by adding these exponents, right? Same base, 3 plus negative 3 is 0. 10 to the 0 has to be 1. So with a lot of these problems, there's different ways you can go about getting the same answer. Okay, let's look at number 2. 2 to the 4th over 2 to the 7th. Again, I can write these all out. I'll show you the quicker way in a second. If I have 4 2's on the top and 7 2's in the bottom, we're going to see a lot of things that, pairs that can cancel out. And you can see that I'm left with 3 2's on the bottom. This will give me 1 over 2 to the third or 1 over 8. Okay, some of you might say, hey, I could have done that a lot quicker using this property you just told me. You're so right. Okay, I can take 4, take away 7. I subtract. I learned that in my property. 4, take away 7. 4, take away 7. You have to do it in the correct order. Okay, 4, take away 7, negative 3. 4 minus 7 is 2 to the negative third power. It's 1 over 2 to the third, which is 1 over 8. So you can see in both cases here, we're getting the same answer. Writing it out is helpful to see where the property comes from, but as you get used to using your properties, you can do much quicker by here. When you're multiplying, you can add those exponents. When you're dividing, you can subtract those exponents. Let's do one more together. This problem has variables in it. We're not going to end up with a nice answer like 1 or 1/8. Our answer is going to have x in it, but we can still simplify this problem. Let's do it the quick way from the start. If I'm multiplying, okay, it's a problem of multiplication, and my bases are the same. I have x and x. What can I do with these exponents? I can add them. I can add them. Okay, I have x to the negative 5 plus 3. Negative 5 plus 3 is going to give you x to the negative 2. I'm going to keep going, putting that negative 2 on the bottom. Okay, this is going to move to the bottom of my fraction, a little arrow there. And I'm going to be left with, that's my final answer, actually. That's my final answer. 1 over x to the second. Oops, sorry. I like that. 1 over x to the second is my answer. Here I have 1/8, 1/8, and 1 as my 3 answers to the example problems. I'm going to ask you right now to pause, do problems 4, 5, and 6 here on your own, see what you come up with, and I'll reveal the answers in just 1 second. Okay, so pause here. All right, hopefully you're back from doing problems 4, 5, and 6. Here are your answers. For the first problem, you should get 36. 6 to the second power will give you 36. For number 7, I tried to trick you a little bit. Sorry about that if you were working on that one for a long time. If you have 7 as a base and 8 as a base, those are not the same. So what we write is can't combine. Okay. And then for number 6, probably several steps going on there, and your final answer should be 1 over 36. If you're not getting those answers, keep trying. If you have questions, we'll talk about it tomorrow. Okay, so we're done with 2 slides. We have 3 more slides to go. Our next slide is a little bit of a digression. We're going to go off of our notes just for one moment, and we're going to try to convince you yet one more time that anything to the 0 power is 1. And we can do that by looking at this new property that we learned. Okay, so what we have to understand is that any number divided by itself is 1. If I have 5 divided by 5, or 5 over 5, I have to get 1. If I have 4 to the third power over 4 to the third power, those are the exact same thing in the numerator and the denominator, and that has to give us 1. Yes, I have some powers here that I could evaluate, but I know because 4 to the third is the same as 4 to the third, that it has to be equal to 1. Okay, let's look at the same problem in another way. I have 4 to the third over 4 to the third, and now I can remember this property that I just learned. These have the same base, 4 and 4, and so I can take 3 and subtract 3. 3 subtract 3. Okay, 3 subtract 3 is 0. So if I have the same problem that I did in 2 different ways, and here I got 1, and here I got 4 to the 0, that means 4 to the 0 has to be equal to 1, because those have to be equal to each other. Okay, so I know we covered this in the first section, but just wanted to review it one more time. Another reason why. Okay, it's important to understand why things are the way they are. So another explanation for why anything to the 0 power is 1. Okay, let's go to our next slide. Our next slide is about fractions with an exponent. 2/3, 2 over 3, all with these parentheses around them to the 4th power. Okay, 2 to the third to the 4th power, or 2/3 to the 4th power. Now this should make sense. If we write it out, this should be 2/3 multiplied by itself 4 times. 2/3 times 2/3 times 2/3 times 2/3. 4 times. Okay, so here on the top, I'm going to multiply across. Remember, I just really multiply these guys across and multiply these guys across. So what's going to happen is I have on the top 2 times 2 times 2 times 2, and on the bottom 3 times 3 times 3 times 3. I don't have to actually find the numerical answer here. I'm just expanding to show you how this will work. But what happens is, as I'm left with this, oopsie, 2 times 2 times 2 times 2 is the same as 2 to the 4th, and this 3 times 3 times 3 times 3 is the same as 3 to the 4th. So if I start with this fraction, 2/3, 2 over 3 to the 4th power, I can basically take out those parentheses by saying, hey, that 4 has got to go on the numerator and in the denominator. That 4 is applied to the 2 and is applied to the 3. Okay, so another key concept we should write down. When raising a fraction to a positive power, raise both numerator and the denominator to that power. Okay, so if you need a second to write that down, that's great. Go ahead and pause and write that down. We're talking about positive powers on exponents, or on fractions right now. A fraction to a positive power. Things get a little trickier when we have a negative power, but that's in the next slide. Okay, so go ahead and write that down. We'll start our examples in a second. All right, I hope you pushed pause and wrote down our important property here in this slide. Let's do 2 example problems. 3/4 to the 3rd power. Well, from my property here that I learned that I need to take this exponent of 3 and attach it to the numerator and attach it to the denominator. Okay, so what's going to happen is on the top I'll have 3 to the 3rd. On the bottom I'll have 4 to the 3rd, making my final answer 27 over 64. Okay, 27 over 64. Our next problem, why don't you guys try this one out? Give it a try, see what happens, come back to me if you want to try it on your own. Push pause and try it on your own if you'd like. All right, so here we go. We're going to go through it. If you tried it on your own, that's great. If you want to follow along, that's okay too. The exponent of 4 has to be attached to both the numerator and the denominator. That 4 gets put on everything that's here on the top and everything that's here on the bottom. So it'll look something like this. The 4 gets attached to the 3. Okay, that becomes 4 to the 3rd power. Okay, 3 to the 4th power. I'm sorry, I said that backwards. 3 to the 4th power. Our coefficient is 3. I have an exponent of 4, 3 to the 4th. Now the d. D to the 2nd power. This is something we learned yesterday. It's called the power of powers. If I have something that is in a parentheses that also has an exponent, I multiply those. Okay? For example, we learned yesterday, if you have x to the 2nd power with parentheses and a 3 here, this is called the power of a power. And what do I do with those 2 exponents? I multiply them. This is just a quick example of something we learned yesterday. So here, back to our original problem, d to the 2nd to the 4th means we're going to multiply 2 times 4. On the bottom, I have e and f. F and e both have an exponent of 1. You don't see it, so you can pop it in there. 4 times 1. 4 times 1 is going to give me e to the 4th. F has an exponent of 1 as well. 4 times 1 is going to give me f to the 4th. I have one tiny step left to go. I got to do 2 times 4, and I should get d to the 8th. Oh, and also 3 to the 4th power is 81. Okay? 3 to the 4th is 81. Okay? So if you need to push pause and go back and review any of this, please do so now. We have one more slide, and then we're all set with our notes. Okay? On this slide, we talked about positive powers on fractions. Our next slide, if you're ready for it, negative exponents on fractions. So here's a little bit of why the formula is the way it is. We're going to start with ab to the negative n power, just any fraction a over b with any exponent that's negative. We know that when I have a negative exponent, I put things on the bottom of a fraction and put it with a 1 on top. So that's the only thing they did here. They moved this entire thing that has a negative exponent a over b, it's a negative exponent, I put it on the bottom. When I put it on the bottom, I get positive n. Okay, my exponent becomes positive once I pop that to the bottom. All right, the next step I'm going to do here is not actually doing any math, it's just rewriting the problem in a different way. 1 over a over b to the n can also be written with the division symbol. Instead of writing this with a bar as a fraction, they're just writing it with the division symbol. Okay, that's the only thing that's changing there. Write the fraction as division. 1 over ab to the n is the same as 1 divided by a over b to the n. Okay, next I'm going to look at, what does it mean to divide? Oops, I'm sorry, not yet. First, I'm going to evaluate this n. When I have an n as an exponent on ab, I can put the n on the a, I can put the n on the b. This is one of our new properties we just learned today. The power of a quotient. A over b with parentheses to the n power is the same as a to the n, b to the n. Now, ladies and gentlemen, we're going to look at this division symbol. And what does it mean to divide? Okay, does it mean when it means to divide a fraction, you're actually going to change it to multiplication and do what with the second thing? That's right, you're going to use the reciprocal. Okay, you're going to change division to multiplication. That's what they did here because they're dividing a fraction. Change division to multiplication and take this second fraction and flip it. It was a to the n on top. I put that on the bottom. B to the n then moves to the top. Now, anything that's multiplied by 1 is the same thing. Okay, multiplied by 1 isn't going to change this at all, so this is really just b to the n over a to the n. And now I'm going to go back and do the opposite of this power of a quotient property, and because I have an n here on the top and an n here on the bottom, I can kind of pull that out and put in the parentheses. And now I have b over a to the n. And I realize maybe this was confusing, but the most important thing is let's look at where we started and let's look at where we ended. What happened here? Okay, a over b to the negative n became, in my process here, b over a to the positive n. What's the only thing that's really changing here? Look at my fraction. It was a over b. It's now b over a. My negative n became a positive n. So this is important. When I have a fraction to a negative exponent. What can I do? All I really have to do is flip my fraction. A over b becomes b over a. And also, my negative n will change to positive n. Okay, so that's your formula. We'll write it in a nicer way in our next slide. Feel free to pause and go back if you need to go back and review this. But our next slide, our last slide, we'll summarize this into a little formula for us. So here you are if you're ready. Our key concept is when a fraction is raised to a negative power, take the reciprocal of the fraction and raise the numerator and denominator to the positive power. So you flip your fraction. Let's actually copy this. You flip your fraction, and numerator and denominator are going to flip. Here it is. It's a nice formula. Okay, you flip your fraction, a over b becomes b over a, and your exponent negative n becomes positive n. Okay, let's do an example. Let's do an example. 3/4 to the negative third power. I really want to get rid of that negative exponent. I don't like negative 3 there. So, what can I do to change it? Well, I can flip 3/4 to 4/3. 3 over 4 becomes 4 over 3. And lo and behold, my negative 3 becomes a positive 3. Okay, notice what happened there. Negative 3 became positive 3. And look at my fraction. The only thing I did was I flipped top to bottom and bottom to top. The reciprocal. Okay, from there, I know that this exponent here on the outside needs to go to both numerator and denominator, and my parentheses can then come out. 4 to the third over 3 to the third becomes 64 over 27. Okay, 64 over 27. Let's do another example. Maybe you want to push pause. Actually, push pause. You can do it. Push pause, give this a try on your own, come back, push play, and see if you got the right answer. do that now. All right, I hope you're back with us. Here we go. Our last problem here. We have a negative exponent of -2. Hopefully you gave this a shot. If you did, this should be your answer. We'll go through step by step. Because I don't like this negative exponent, I want to change it to positive. Don't worry about this being a big fraction. Just simply switch this 2x to the second power here on the bottom and our y to the third power from the bottom to the top. So all I did was flip this, and my -2 became a +2. Next, I just go through the steps to evaluate. Okay, a power of a power. Y to the third to the second. We multiply those. Okay, we multiply those. 3 times 2 makes 6. Here, same thing. This 2 needs to get applied to all of the pieces here on the bottom. The coefficient of 2 gets my exponent of 2, so that becomes 2 to the second power. My x to the second means I multiply this 2 and this 2, making x to the fourth. Okay, I'm almost there. My last step is simply this piece here. 2 to the second becomes 4. Okay, so hopefully this is our answer. Again, feel free to ask questions if you have them tomorrow, but try and go through if you're feeling confused. Feel free to hit pause. Feel free to go back and review anything that you'd like to review. As of now, your notes have finished. If you feel like you're still confused even going through these notes, feel free to look at the textbook. Okay, maybe the textbook is clearer for you. There are some nice boxes that say know this or know it notes. Feel free to go back and look at those nice yellow boxes and see if that's easier for you to understand. Okay, so this is where we end. If you have any questions, go ahead and bring them to class tomorrow. And I hope you enjoyed section 4 of chapter 7. Have a good night.